1, 3, 7, 13, 21. What do you notice about this sequence? You might notice that the difference between 1 and 3 is 2, 3 and 7 is 4, 7 and 13 is 6, and 13 and 21 is 8. And that the difference between those differences is 2. Now when the difference between the differences is the same, that means the sequence is formed by a quadratic equation. In this case, y equals x squared minus x plus 1. So when you substitute the numbers 1 through 5 in for x, the y values you get give us our sequence. So what's so interesting about this sequence? Well, it just so happens that there are many ways to construct this sequence without using an equation. Let's look at 4 different ways of doing this. In the first method, we'll start with a pyramid. Fill the pyramid up, counting by ones, up to 25. Do you see the sequence? It goes right down the middle. With this next method, you start with a grid. In the middle of the grid, you put the number 1. Then you count by ones while moving clockwise, like this. Do you see the sequence? It appears right along the diagonal. This next method is slightly more complex. It turns out our sequence is hidden within perfect cubes. We will take a look at the first 5 perfect cubes. 1 cubed is 1, since 1 times 1 times 1 is 1. 2 cubed is 8, since 2 times 2 times 2 is 8. What is interesting about perfect cubes is that for every perfect cube, there exists consecutive odd integers that sum to that cube. For 8, those consecutive odd integers are 3 and 5. 3 cubed is 27. The consecutive odd integers that sum to 27 are 7, 9, and 11. 4 cubed is 64. The consecutive odd integers that sum to 64 are 13, 15, 17, and 19. And 5 cubed is 125. The consecutive odd integers that sum to 125 are 21, 23, 25, 27, and 29. Do you see the sequence? The first numbers in the sets of odd integers make up our sequence. This last method is quite unexpected, but very satisfying. What we're going to do is draw some circles. Each time we draw a new circle, we're going to count the number of enclosed regions. And when we draw a new circle, we'll do it in such a way that we create the maximum number of enclosed regions. Let's start with 1 circle. 1 circle gives us 1 enclosed region. Let's add a second circle. 2 circles gives us 3 enclosed regions. 3 circles gives us 7 regions. 4 circles gives us 13 regions. And finally, 5 circles gives us 21 regions. Keep in mind that in order for this to work, you have to create the maximum number of enclosed regions every time you add a circle. Thank you for watching Amusing Maths. Enjoy your day, and see you next time.